In this video, I want to talk about the idea of a change of basis. In our previous video, I talked about coordinate systems and how to look at different coordinate systems and coordinate vectors. And now the idea is I want to move from one coordinate system to another. And I want to try to figure out how to do this in the most effective way. Let's suppose I have two given bases of a vector space V, and we're going to call these bases B and C. I also know the relationship between them. I know that the vector B1 is equal to 6C1 plus 3C2, and B2 is equal to minus 9C1 plus 4C2. I want to find the coordinate vector of x with respect to C, given that x is equal to 2B1 plus 6B2. Well, let's look at what we do know about x. It's 2B1 plus 6B2. I can then use the things I know about B1 and B2 and substitute them in. So this is 2 times 6C1 plus 3C2 plus 6 times minus 9C1 plus 4C2. This will give me 12C1 plus 6C2. The next one, minus 54C1 plus 24C2. And from here, we just need to rewrite. 12C1 minus 54C1 is negative 42C1. 6C2 plus 24C2 is 30C2. Therefore, my coordinate vector of x with respect to C is equal to negative 42, 30. So I was able to figure it out, particularly because I had these relationships between my basis vectors. I want to determine if there's a more effective way to do this. So let's start with two bases of my vector space V. Then there is actually a unique matrix P from B to C such that the coordinate vector with respect to C is equal to this matrix P times the coordinate vector with respect to B. So I can find a change of basis matrix that I can multiply coordinate vectors by to get the resulting coordinate vector in the new basis. And in fact, the columns of this change of basis matrix are the C coordinate vectors of B. So let's do an example where we see how this is used. I'm going to start with two bases, B and C. I also know that B1 is C1 minus 2C2 plus 9C3, B2 is 9C1 plus 7C2 plus 4C3, and B3 is 8C1 minus 4C2 minus 7C3. And I want to find my coordinate vector of x with respect to C, given that x is 4B1 plus 8B2 minus 2B3. And this is very similar to the first example I did in this video. But we want the more effective way, and I want to do this by finding that matrix, the change of basis matrix P. And like I said, the change of basis matrix comes from the C coordinate vectors of the basis B. So I'm going to use these coefficients for my columns. My first column is going to be a 1, minus 2, 9. My second column will be 9, 7, 4. And my third column is 8 minus 4 minus 7. So what we have from there is that the coordinate vector of x with respect to C, which is what we want, is equal to this matrix, the change of coordinate matrix, times the coordinate vector with respect to B, which is given by these coefficients, 4, 8, minus 2. And then from there, we just need to multiply. Doing my first row by my column, 1 times 4 is 4, plus 72 minus 16 is 60. For my second row, I would have negative 2 times 4 is negative 8, plus 56 plus 8 gives me 56. And then my third row, 9 times 4 is 36, plus 32 plus 14 gives me 82. So here's my coordinate vector with respect to C. While this is helpful if I know how my two bases relate, it's not helpful if I don't have the coordinate vector of one with respect to the other. So in general, how do I actually compute this? And we start by forming a matrix. The left-hand side will be the vectors from the basis C. The right-hand side will be the vectors from the basis B. And then we're going to reduce this. We are going to reduce it to get I on the left-hand side, and then the right-hand side will be exactly what we want. So this is one of the main reasons we write this as C and then B when we really want B going to C, is so it helps us remember to set up this matrix appropriately. To go the other way, so if I take the inverse of this matrix that goes from B to C, I get the matrix that goes from C to B. So if I want to switch the order, it's the same as taking the inverse. So let's look at an example. Here I have two bases, B and C, and I want to find both of my change of coordinate matrices. We're going to start by looking for the one that goes from B to C. For this, we set up a matrix. We have C on the left and B on the right. And now we just need to row reduce this. When we do, we get 1, 0, 0, 1 on the left. The right-hand side becomes 1/3, 5/3, 2/3, and 1/3. Therefore, my change of coordinate matrix to go from B to C is given by this right-hand side. 1/3, 5/3, 2/3, and 1/3. To go the other direction, we want to take the inverse. So let's start by finding the determinant of this. Multiplying this way, I have 1/3 times 1/3, minus multiplying this way, 5/3 times 2/3. This is 1/9 minus 10/9, or -1. So my matrix to go from C to B is going to be negative. We switch the elements on the diagonal. We change the sign of the other two. So multiplying the negative sign through, we have that the other change of coordinate matrix will be -1/3, 5/3, 2/3, and 1/3.